French fries are one of the most widely consumed foods on Earth, served in restaurants, fast food chains, stadiums, and homes across nearly every country. Yet the journey from raw potato to perfectly crispy fry is far more complex than most people realize. What looks like a simple golden stick is actually the product of precision agriculture, optical sorting, controlled chemistry, high-temperature oil engineering, and some of the fastest food processing lines ever built. Producing fries by the millions requires turning an unpredictable agricultural crop into a uniform, reliable product that cooks the same way every time. And today on The How Factory, we're going deep inside modern fry plants to see exactly how potatoes are transformed into crispy French fries at massive industrial scale. Potatoes have been cultivated for more than 7,000 years, originating in the Andes before spreading across Europe and eventually the world. For centuries, potatoes were eaten boiled or roasted, but the fried potato rose to prominence in the 18th and 19th centuries as cooking oils became more available. The modern French fry explosion, however, only became possible in the 20th century, when freezing technology and industrial food processing allowed fries to be produced centrally and cooked anywhere on demand. Today's fries are engineered as much as they are cooked. The process begins on specialized potato farms growing varieties bred specifically for French fries. These potatoes are long, dense, and low in sugar, traits essential for producing fries that brown evenly without burning. Farmers manage irrigation, soil nutrients, and harvest timing with extreme precision. Sugar levels are monitored closely because excess sugar causes fries to turn dark and bitter during frying. Once mature, potatoes are harvested mechanically, lifted from the soil, cleaned of dirt, and transported quickly to processing plants. At the factory, potatoes arrive in massive truckloads and are immediately unloaded into receiving systems. Conveyors carry them through stone traps, air separators, and washing flumes that remove dirt, rocks, and debris. Cleanliness at this stage is critical. Any foreign material could damage equipment or contaminate food. The potatoes then pass through optical sorting systems equipped with high-speed cameras and lasers that scan each potato in milliseconds. Misshapen, bruised, green, or damaged potatoes are automatically ejected. Once sorted, potatoes enter peeling systems. Most fry plants use steam peeling, where potatoes are exposed to high-pressure steam for several seconds. The sudden pressure release causes the skins to crack and separate from the flesh. Rotating rubber brushes remove loosened skins with minimal waste. This method preserves potato mass while producing smooth surfaces ideal for cutting. After peeling, potatoes are inspected again and trimmed if necessary. Any remaining eyes or defects are removed automatically or manually, depending on plant design. The goal is uniform raw material because uniform fries cook evenly. Now comes cutting, one of the most visually dramatic stages. Potatoes are fed into high-speed water knife cutters. Pressurized water shoots the potatoes through stainless steel cutting grids, slicing them into precise fry shapes in a fraction of a second. Different grid sizes produce shoestring fries, standard fries, or thick-cut varieties. Water cushions the cuts, preventing bruising and breakage while maintaining speed. Thousands of potatoes are cut every minute. Fresh-cut fries immediately enter water channels where surface starch is washed away. Removing excess starch prevents fries from sticking together and improves final crispness. Water temperature and flow rate are carefully controlled to avoid damaging the fragile cuts. The fries then move onto vibrating screens to remove excess moisture before further processing. At this point, fries may look finished, but they are far from ready. Raw potatoes contain natural sugars that must be managed carefully. Fries often undergo blanching, where they are briefly cooked in hot water or steam. Blanching removes excess sugars, stabilizes color, and partially gelatinizes starches inside the fry. Timing is critical. Too little blanching causes uneven browning, too much makes fries limp. After blanching, fries are cooled and dried using air knives and conveyors. Surface moisture must be removed before frying because water causes oil splatter and uneven cooking. The fries now have a pale, slightly translucent appearance. Next comes par frying, the step that defines modern French fries. Fries enter massive continuous fryers filled with carefully filtered vegetable oil, typically canola, sunflower, or soybean oil. Temperatures range between 170 and 190 degrees Celsius. The fries travel through the oil on mesh belts, cooking for a short, precise time. During this stage, moisture rapidly escapes from the outer layer, forming the initial crispy shell while the interior remains soft. Oil management here is critical. Oil quality, temperature stability, and flow must be maintained constantly. Sensors monitor oil breakdown, moisture content, and particulate buildup. Fryers run continuously, often 24 hours a day, processing tons of fries without interruption. Once par-fried, fries exit the oil and pass through de-oiling systems that shake off excess surface oil. Some fries receive coatings at this stage, thin starch or batter layers that enhance crispness and help fries stay crunchy longer after cooking, especially in fast food environments. These coatings are nearly invisible but play a major role in texture performance. After frying, fries are still hot and fragile. They move immediately into rapid freezing systems. Industrial fry plants use blast freezers or IQF tunnels, where extremely cold air freezes fries in minutes. Rapid freezing prevents large ice crystals from forming, preserving texture and preventing mushiness. Each fry freezes individually rather than clumping together, allowing easy portioning later. Once frozen, fries enter inspection systems. Optical scanners check size, color, length, and defects. Broken, dark, or irregular fries are removed automatically. Quality control teams also pull samples for taste, texture, and moisture testing. Fries must meet strict standards to ensure consistent performance in restaurants and homes. Packaging is the next high-speed operation. Frozen fries move into weighing and bagging machines that portion precise amounts into bags. Packaging materials are designed to resist moisture and oxygen, protecting fries during storage and transport. Bags are sealed, coated, and grouped into cartons at incredible speed. Cartons are stacked onto pallets by robotic palletizers and wrapped for stability. Finished pallets move into frozen warehouses where temperatures are kept well below freezing. Cold chain integrity is critical. Even short temperature fluctuations can affect fry quality. Distribution is global. Fries are shipped by refrigerated trucks and ships to restaurants, supermarkets, and fast food chains worldwide. Some fries will travel thousands of kilometers from factory to fryer. Inventory systems track batch numbers, production dates, and destination markets to ensure freshness and traceability. Behind the scenes, food safety and sanitation dominate every step. Fry plants operate under strict hygiene protocols. Equipment is cleaned using automated systems. Oil is filtered continuously. Water used in washing and blanching is treated and reused where possible. Sensors and software monitor the entire process in real time. Sustainability also plays a growing role. Potato peels, trimmings, and rejected fries are repurposed as animal feed, bioenergy, or fertilizer. Energy-efficient fryers and heat recovery systems reduce fuel use. Some plants even reuse waste heat from fryers to preheat water or air elsewhere in the facility. What makes French fry manufacturing remarkable is how it tames natural variation. No two potatoes are exactly the same, yet every fry must cook, brown, and crisp the same way. Achieving that consistency requires controlling chemistry, moisture, oil interaction, and temperature at every step, all at massive scale. From underground potato fields to roaring fryers, from precision cutters to sub-zero freezers, the journey of a French fry is a tightly choreographed industrial process hidden behind a simple menu item. Every crispy bite represents agriculture, engineering, and logistics working in perfect synchronization. And that is exactly how potatoes are washed, peeled, cut, blanched, fried, frozen, inspected, packed, and shipped, transforming humble tubers into crispy French fries produced by the millions every single day. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the farms, factories, and systems behind the foods we love.